I'm Anil Kumar, and here is extremely important question on composition of function. The question here is, given the graph of y equals to f of x and the function g of x equals to x plus 3, sketch the graph of f of g and g of f. Now this is a test problem. You can pause the video, answer the question, and then look into my suggestion. In this particular solution, I will also teach you that when we are doing f of g, then how the functions get transformed. And how is it that g of f and f of g are so different, right? So let's consider first f of g. So when I say f of g, that means g becomes the inside function, right? So we are already given f of x here. So that should be equals to f of, now if I write g instead of x, I get what? I get x plus 3. Now f of x plus 3, it means that the function f of x which is given to us has been translated horizontally 3 units left. Do you understand? So this means horizontal translation by 3 units. So let me write down. What does this mean? This really means three units left. Is that clear? So when you sketch the graph, you will sketch the original function, each and every point translated 3 units left. So minus 2 will be at 1, 2, 3 units around here, right? So this point moves here. 0, this 2 is at 0, so it will come at minus 3. So this line will be translated like this. Now this point 2 will move 3 units to the left, so we'll get that as our function, and this point which is at 4 will now come at 1. So each and every point on this graph moves 3 units left, and this is f of g for you. I hope that's very clear, right? Now let us see what is g of f, right? So let's see what is g of f. Now g of f means this is the function g of x. Now this x is replaced by f of x. So we could write this as g of, if I say f of x here, so if I write f of x, then what do I get? So I'm replacing x with f of x, right, in this function. So I get f of x plus 3. Do you understand? That is what you get. And what does that mean? It means that the function f of x is translated vertically by 3 units. You get the point. So in this particular case, the function is translated vertical, so it relates to vertical transformation, right? So when we do g of f, so vertically if I move this point up by 3 units, it will come at 5. This is 0, it will go at 3. And this is at 1, so it will be appearing at 4. So let me connect them. And this is at 2. Okay, so it will go at 5, so it is there. So kind of like this. Do you see that? So this function becomes g of f. So that is how the functions get transformed when we do composition of functions, right? So if I'm doing f of g, in that case all transformations are relating to horizontal, but if I do g of f, it relates to vertical with respect to f of x. You get the point. So that is the concept which you learn from here. We'll take one more example which will involve stretches rather than translations, but concept is same. When you do f of g, it will be horizontal stretches and compressions, but if you do g of f, it will be vertical stretches and compression. This is very important to understand. So I like you to go through these 2 videos once again together so that you understand the whole concept. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.